Practice number 2 gives you an opportunity to practice what you just learned. So let's find out what equation generated this graph. You do this on your own. Pause the video, see if you can determine the equation, and then when you have your answer, resume watching the video to compare your answer with what you see on the screen. And welcome back. Let's see how you did. First of all, let's talk about the scaling of this graph. Going from 0 to 10, we notice the spacings. We have 2, 4, 6, 8, 10. So each line across the x-axis is 2. Also going up, we have the same spacing, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So we know what these lines represent. So the x-intercept right here is halfway between 0 and -2, which makes this at -1, 0. Same thing for this x-intercept. This occurs at 9, 0. So knowing the x values, the x-intercepts are at -1, 0, 9, 0. So x is equal to -1 and 9. Using our general equation, I make the substitution. I replace b with -1, and I replace c with 9. So we use those factors to write the equation as y is equal to a times the quantity x plus 1 times x minus 9. Now our next step is we're going to substitute values of x and y for a data point somewhere on the graph into the equation. Now we can pick any one we want. I'm going to pick this one here, 4, 25. I know this is 4 because it's 2, 4. And I go up here, it's 20, 22, 24, and halfway between is 25. So this point 425 is going to get substituted into x here and here for 4, and y is going to go into is replaced with 25. That will help us determine the value for a. So making those substitutions, where x is replaced with 4 and y is replaced with 25, we find out that a is equal to -1. So we make our final substitution, replace a with -1, gives us this equation right here. Y is equal to negative times the quantity x plus 1 times x minus 9. And you have now found the equation that generated this graph. One note just for verification, the negative value for a verifies that the parabola opens in the downward direction. So anytime the coefficient of a is negative, this parabola will open downward. The graph of the function y equals x squared plus x minus 2 is shown. That's what this is. What are the solutions? Now, truthfully, there are infinitely many solutions. That's the purpose of the green line. But we're talking about very special solutions known as roots. Roots are values of x which will make this equation equal 0. And we can determine the solutions or the roots based on the graph. When we look at the x-intercepts, which here's an x-intercept, and here's another x-intercept, x-intercepts on a graph are roots of an equation or special solutions of an equation. And we look at the x values, -2 and +1, and those are the solutions for this equation, which will make it equal to 0. So when all said and done, the graph of the function y equals x squared minus 6x plus 9 is shown, as indicated right here. We want to determine the number of zeros of y. Now there's two ways we can do this. The quick and easy way is by looking at the graph, and we see here that the graph intersects the x-axis at one point. So we see there's 1, 0. If we didn't have the advantage of the graph, we could also use the discriminant, which is b squared minus 4ac. Knowing that a is 1, b is -6, and c is 9. So making the appropriate substitutions, we would have -6 squared minus 4 times 1 times 9. This comes out to be 36 minus 36, which is 0, and when the discriminant is equal to 0, that tells us there's one solution. So whether we look at it graphically or algebraically, both ways will tell us that the correct answer is B. There's only one solution. The graph of the function y equals x squared minus 6x plus 9 is shown. what are the solutions? So in this question, we're not asking how many solutions, we're just asking what those solutions are. Now, graphically, we can look at this, and we see it touches the x-axis right here at one point at x equals 3, or the coordinate 3, 0. So graphically, we see it only touches at x equals 3. If we didn't have the advantage of the graph, we could solve this algebraically by taking x squared minus 6x plus 9 and setting it equal to 0, because the x-axis occurs when y is equal to 0. And when we factor this, we have x minus 3 squared. And x minus 3 squared means we have two of them, so we're going to have x minus 3 is equal to 0, and the other x minus 3 will equal 0. And that's just a long way of saying that occurs when x is equal to 3. So either way, whether we solve it algebraically or graphically, we see the correct answer is A, only at x equals 3.